All right, welcome back after a brief hiatus because I had a child. Today we're going to focus on using R to make movies, and I've sort of started a document here called Rain Movies because we're going to use precipitation data, and this is going to be on GitHub under Fancy Viz. And so the reason you would ever want to make a video versus a static image plot is that often videos can really convey some temporal dynamics. So maybe you have a time series of data and you want to show it in a way that the x-axis is not the time plot. So you could have a video scroll through years. Or another time is that you might want to use it is with explicitly spatial data. So today I'm just going to sort of show you a couple different ways to make videos. We're going to use this package called Ream, which downloads airport precipitation data. And so the very first thing we need to do is get some airport data. So let's still go ahead and use the Ream function called Ream networks. And basically this is just a simple function that's going to spit out all the available networks that have data, and you can mostly we need this to sort of figure out how they're labeled. So you can see they're sort of either country and then double underscore ASOS or state, like Alaska ASOS. So by that logic, we could do co-stations. We can make, I'm going to leave that there. Look for network names. So that's just going to print. And I'm actually going to comment it out. And then what we actually want to keep is Colorado stations only. So we'll focus our analysis on Colorado, and we'll do Ream stations. And then we're going to do the network name, and we're going to just assume that this AK ASOS and AL ASOS is the same, and we're going to just assume it's CO ASOS. And so what that's going to do is it's going to call to where this data lives, which I think is the University of Iowa has collated all airport station data. And it's going to call that, and it's going to make a new data set called co-stations, which we can quickly view. And what I want to do is make a video comparing sort of precip from one location on the Front Range to another. So the first one I think I actually want to use is the Air Force Academy. This is an interesting area because it's one of the higher elevations along the Front Range, so it's quite a bit higher than, say, Fort Collins. So let's go ahead and use AFF. So we'll do networks, or actually stations, and we'll make a vector that holds these stations' names. So we'll do the Air Force Academy, and then let's see if there's a Fort Collins one. Okay, so there's the Fort Collins AWAS, which could mean that it's a different type, but that's okay. So now we'll have FNL. And I'm going to comment this out. So now we just have a vector with these two station names. And then the next one, this is just going to be finding our station names. So we found our station names. The next thing we want to do is actually download the data. So download. And to do that, we're going to look at the last Ream function, which is going to be Ream measures, which is the way you download Ream data. I don't know how this works just yet, so let's go ahead and try one. So we'll say AFP, so Air Force Precipitation, and we're going to do Ream measures station equals AFF, date start equals, let's do 2018-01-01. Actually, let's do a water year, so we'll do 10:01, and that will go to 2019 date end. Let's just do a full water year. That's gonna equal 2019 9. Maybe I'll put it at 0, 9:30. Okay, hopefully that works. So now it's gonna go call this data. I'm hoping it doesn't take too long. Okay, that's relatively fast. Let's go ahead and take a look. Head AFP. So it looks like it has data every hour. And then it has the long and the lat, and it has temperature, relative humidity, and a bunch of other things. I think head is not showing me everything, so let's go ahead and use view. Visibility. There's a bunch of random codes that we should probably read the metadata. Checking if there's ice. Okay, so now we have this sort of like basically data set, and we have it for the Air Force Academy, and then we can just download it again for Fort Collins. And we'll just change this to FNL. Fort Collins takes a lot longer to download. Maybe AWAS has a lot more data. We might change it if this takes too long. Oh yeah. So it must, you see how on the data that came in had 100,000 observations. So it must be, yeah, every 5 minutes. So that's extremely high temporal resolution. I might just change it to somewhere nearby. Let's say Greeley. Oh, they're all AWAS. Maybe there's a Loveland. Don't see it. There are a bunch of different ones. I wonder what front range is. Where's that? We'll just keep it this way. And you'll see immediately we have sort of a problem in the data structure in that this one is on hourly and this one's on daily. So we'll probably have to convert these to daily just to sort of get this going. And we'll just say convert both to daily. So all I'm going to do here is sort of summarize some relevant parameter. I'm going to look at Fort Collins. And I just realized I was going to plot the temperature data, but Fort Collins, oh, they only measure temperature once a day, it looks like. Which is interesting. Maybe once an hour. So if we just do a daily temperature average, that'll work. I'm just making sure that it has the same. We have barometric pressure. We just have these ice accretion and other things. Okay. So now we have both of these data sets, but we need to convert them to daily. So let's go ahead and say FCD, and that's going to be FC. We're going to mutate and make a new column. For some reason, the date time column is called valid, which I don't really understand, but we'll just make one called date, and we'll do as.date valid. And then we're going to group by date and station. And I don't know if this station, I wonder if we could do this. I was going to try to download them both at the same time, but I don't think you can. Group by date and station. And then for now, we're just going to, and I'm going to keep long and lat actually, so I'm going to also group by those. And then we want to summarize, and we'll just say temp equals mean temp Fahrenheit. So we'll have to remember that's temperature in Fahrenheit, which I think we can remember. So now this is just a daily mean temperature. Hopefully that runs pretty quick, and then we get 358 days, which tells me that there's some missing data. There should be 365. And then we're going to do the same for the AFP data. And actually, I'm going to do something semi-intelligent. I'm going to stack these first, so bind rows AFP. And so this way I'm doing all of these analyses just once. So I'll call this daily P. And so that should give me 721. So that means now we have a long data frame, which we can look at. And it's going to be much simplified. It's just going to be temperature and then oh, and I need to do mean temperature, and then I forgot to do na.remove equals true. And that's just because we knew that they only took temperature every hour instead of every 5 minutes. So there's a bunch of NAs. And so now if I go to head daily P, we should have values for all of those. And we can see the different temperatures at Air Force Academy and Fort Collins. Randomly this day on the 3rd, and they were kind of the same, the average. And you know what? Let's go ahead and actually make this data a little more interesting, and we'll do mean, min, and max just to see if they have different mins and maxes. And then max temp. Okay. So now our daily P data looks like this, and we have some different data. We can see the sort of range of temperature values. Okay, and so now we have our data sort of in the proper format, and now we're going to use this package called GGAnimate to make a video. So first I'll just sort of show you the animate. Just how GGAnimate works. Basically, you add one line that basically makes this move. I think this one is what I wanted to look at. And so you add this transition time, which basically makes it so that it's going to float around in years. So what we can do is sort of keep this aid in mind. And what we want to do is we're going to make a ggplot. We're going to make it of daily P. The aesthetics are going to be, the x-axis is going to be, we'll just do time, so date. And y is going to be, let's just do the mean temp to start. And we are going to do geom_point. So if you, oh, I do need to do color equals station. So if you were doing sort of a normal plot, this is what you would, this is the sort of plot you would make. But we wanted to make this an animated plot. So we're going to do plus labs title equals. So here I'm just giving it a title that will be varying in time. So we'll do year, date, and then it's going to take that date from the date column, which we know is going to be called, is the frame time. And I'm just reading the help file for the GGAnimate to remember that it's called frame time. And then X is going to be, the X-axis is just going to be the date. This is not going to be the most exciting video, but it's going to get us started. And the Y is going to be mean temp Fahrenheit. I should put a degree symbol, but I'm too lazy to remember how to add degree symbols. And then we'll do transition time, and that's going to be date. And let's see if we can get this to run. And you know what I'm going to do, actually? I'm going to slice this just so we only do like the first 10, just to see if it works. When you're making these videos with hundreds or thousands of plots, what you're going to generate is hundreds of thousands of plots. So you want to actually sort of test it on a smaller subset first. So we'll do ggplot. Time data. Must be either integer, POSIX. Well, what? Oh, I don't think this should be quoted. Dang, such a simple thing. Let's put the title back in, see if it works. And this should not have ever been quoted. Oh, forgot that. Okay, so now it is rendering this movie. It'll pop it up, hopefully, on the side. I don't know how you control this sort of name saving. Okay, so now you can sort of see these temperature differences fly along in this little random video. You can also obviously see too, we have a problem where it's only showing the day of, so the sort of, it's not showing the cumulative data. It would be nice if it was like leaving a trace. But this is sort of the first little video, and the main things that are the GGAnimate bits are in here. So we're adding this transition time, and then we're adding the aesthetics of how it interpolates between different aesthetics. Okay, after a brief pause where I learned a little bit more about GGAnimate, I'm ready to sort of explain some of the things that we're seeing in here. So I've made this ggplot call, I've made it actually into a ggplot object. And with the animate function, which is part of GGAnimate, we can actually control the number of frames. So earlier we were producing 100 frames, as you can see here, frame 100. And we really just want to produce the number of frames that is in the data, since we want to eventually generate a movie with all the data. So let's go ahead and say animate P1, and we'll say n frames. So the number of frames equals the number of rows in our data. So that's going to be slice P for now. And if we do that, it's just going to generate 10. You can see it's a lot faster because it's not generating 100. And now it's just like ripping through this visualization really quickly. That's probably about the right speed when we want to generate hundreds of these. So let's go ahead and do slice P with 100. And then we'll do that again. And we'll animate it again. There we go. It's just going to take a little bit longer. And then we can look into the animate function once this is done and actually see what else we can control in here. We can control the sort of frames per second. You can see it's doing a frames per second calculator there. Now it's going to generate 100, but this time when it generates 100, it's going to be the sort of larger data set. So we're going from October 1 till sort of December and sometime. And you can see we still have this problem where we're not leaving a trace. So after some more learning on my part, I learned how to make a trace. So I'm just going to copy a bunch of this text code up here. And the key to leaving a trace is to change this transition time from transition time to transition reveal. And so what the reveal says is, hey, everything before that date keep. And so we'll just add this geom line. There we go. And now we're not using a frame time. So we're just going to change the title to 100-mile temperature difference. Kind of a dumb title, but this is not about proper titling. And then we're going to just use slice P again. Again, just to test it, I'm going to make it a smaller data set, so we'll just use 20. And we'll do that, and then we'll animate it. And it's going to render fairly quickly, hopefully. And then now we can see these lines, which is great. So as we sort of code the next bit, I'm going to actually just leave this running and have it generate the daily full time series. And just because I don't like the basic colors from that, I'm going to do scale color view also. So now we'll do, this is actually going to be P2. We're going to do P2, and then we'll do animate P2. And in row, we put daily P there, we put daily P there. So this should generate about 350 plots. And it'll take a long time because there's a lot of them. Great. Okay, so that's kind of a basic, I don't know how I just made that little smiley face. That's kind of a basic animation that's not particularly exciting, so let's make one that's maybe a little bit more interesting. If we look at the daily P data, oh, I can't look at it. That's okay. We can look at it up here. We have this other column called P01I, and so that's the cumulative rainfall or precipitation for the whole previous hour. And I think Fort Collins has the same column. Yeah, it does. And so it fills it with NAs. This one fills it with zeros. So we'll need to sort of make sure that that's okay. And what we're going to do is we're going to change daily P up here, and we're going to actually include precipitation this time. And what we'll do is daily P will be the column name. And what we're going to do is a sum. So the total amount of precipitation in a day would be the sum of this hourly column. So sum of P01I. P01I. And we're going to remove NAs. And that should just give us a daily sum of the precipitation. That video is sort of still generating, so we won't be able to run this until it's done. But once we have a daily estimate of precipitation, what I want to do is make a video where we have the state of Colorado and each of these stations, and they'll flash when they get rain, and they won't flash when they don't get rain. So hopefully we can make that video relatively quickly. And we're going to use a slightly different approach to do that, including this USA boundaries. So we'll do, I don't care. We'll do USA, and that's going to be all US states. And then we're going to do Colorado, which is going to be USA, and it's going to be filter name equals Colorado. And I think this should work. Luckily, our video is about to be done, so we'll see a full year of this time series now. It's probably going to run a little bit slow because it's 365 days. Oh, we have more, far more. I wonder why. Maybe it just automatically. Oh, I should have done inrows daily P, and I should have divided that by 2 because there's 2 different stations. So that's just kind of my bad. But here now we have this full time series of data, and you can see most of the time the Air Force Academy and Fort Collins are sort of in sync with their mean temperature, which makes sense. They're only 100 miles apart. But occasionally the Air Force Academy gets quite colder, which is maybe weather patterns hit there first, or they never hit Fort Collins. I'll be curious as this goes into summer. Obviously, with this kind of data, you might want to have a different frame size. So this is mostly sort of relevant on the horizontal axis, so we could widen that. But it's just kind of a helpful way to look at data. But this is a pretty boring video. You could also look at this plot just statically and sort of get the same basic understanding, which is why we're doing this USA and Colorado stuff. So I'm also going to show you a new package called tmap that we haven't used yet. It's just a really fast way to make maps. Tmap. So tmap hopefully is loading. And basically what we can do with tmap is we can say tm shape, which is Colorado, and then we'll say tm polygons, and I'll just make what is Colorado? Should be a SF object, yeah. So Colorado, you can't really tell, but that is Colorado because there's nothing really there. But then what we can do is take our daily P, and we kept those lat longs, so we'll make it a, first we need to rerun that code that we ran up here. So now we have this daily P summary column, which is the total amount of precip. And down here, we're going to have the SFP. So we're going to make it a spatial object, and we'll take daily P st as SF, chords equals C long. No, what is it? Lat, long lat. It's long lat. And then the CRS is 4326, I assume. And then what we can do is add another shape to this map, tm shape SFP. We can make them tm dots. And we'll do color equals station, so that they get colored slightly differently. Oh, they're tiny, tiny, tiny things. So we'll do size equals 10. Let's see how big that gets them. Okay, that's probably too big. Okay, so now we have size equals 5. Obviously, it would be better to have some kind of imagery or topography map of this data to make this look a little bit prettier. You know what? I bet with Elevator we could really quickly download it. So let's go ahead and do that. Co-eliv. And we'll just download it at the really coarsest data set. We did this in a previous video. So we'll do git eliv raster. We'll do it for co, and we'll do the z, which is, if you remember, is that zoom level. We'll do it at like the zoom level of like 4, so that it's at the really broad scale. So it's going to download this DM pretty quickly. Okay, after fine-tuning some of the style, now we have something that I think actually looks relatively nice. And so now we have this elevation map and our 2 stations, and what we want to do now is make a video where these flash only when it's raining. And so to do that, let's just go ahead and label this chunk the static background plot. We're going to use a different animation package, just called animation, which is actually the package that GGAnimate is built off of. Quick plot. And once again, we're going to go ahead and slice this data just so that we don't generate it a million times. So we're going to do slice SF, and we're going to just do SFP slice. And we'll just look at the first maybe 30 while we're generating the plot. Actually, 30 is going to be a lot. We'll do the first 10. Hopefully it rained in the first 10 days. It may not have, because it doesn't rain much in Colorado. Okay, so now we copy all this code up here because this generates the sort of plot that we want. It stylistically looks okay. And what we're going to do is we call this command called save movie, save GIF. And that has basically you open bracket and an open curly bracket. And then inside of that save GIF call, we're going to have a for loop. So for I in 1 to n row of slice SF. So that's going to be just 1 through 10. We're going to basically plot only the dots when there is data. So now we copy this guy and we plot it in here. And we have we have polygons. These are all not changing. So we have TM shape and then the raster's not changing. And then this is the only one that's going to change. So we want to subset SFP to only be there to only be plotted if it has, if there's data. So basically we'll put the map, the base map, let's call it base map. We'll make all this stuff here. And then we'll only add this the SFP if it has, if it rained that day. So we'll do sub SF or sub, yeah, that's fine. And we'll say SFP filter daily, let's say the date. We want this to go over time. So we actually want to make a date, full dates. So we want to do unique SFP date, and we want to sort that. So now if we look at full dates, it should start in October and go on from there. Oh, yeah, great, it does. Okay, so now we have this thing called full dates, and we want to do, what we want to do is say first, we just want to make sure we're filtering it so that date is equal to the full dates sub I. So just the first, we're going to just progressively go through. And then we want to say, so that's just going to be one day. I is not found yet, so we can't test it. So let's just make I 10. And so now we'll have sub SF should just be 2 observations because it's at each station. And then we want to say, we'll filter this again, and we'll say daily P has to be greater than 0. This is fairly simple. And then let's see. So for that one, only one of the sites had any rain or any precip, and that was at the Air Force Academy. And it was a very small amount, but it did have some. So you can see 0.0101, so that's great. And so basically down here, what we want to do is create an if statement that says if the n row of sub SF, so the number of rows is greater than 0, then I want you to plot this dot. So we're going to add base map, and that's going to go plus this stuff. So here we'll make the base map, and actually we don't even have to, this is wasteful. We don't have to do this in the loop. We just can make this base map once outside of the loop. So we're not making it every time, which is great. So now we made the base map, and then we're going to add that base map to this sub SF. And hopefully when I do this, because that day only one of the places had data, only that one gets plotted. And so if neither of them have any data, then we'll just plot base map. And just because what we're going to do is actually call this map final map. So we're going to actually just assign it as an object. And here we're going to assign it as the same object name. And then now we're still inside the loop. We're going to print that final map. And just because I want to test how this is going to work, I'm going to change the I to like equal 8, and maybe that, hopefully that's a day where it didn't rain in either place. So sub SF, oh, still it rained. Let's say I equals 1. Okay, so that one it didn't do anything. So let's see what final map will do when there's no data for either of them. It should plot with no data. Great. So now we're going to make a video that's going to be that's going to flash when we have those, and then here we can add some controls. So we'll just I'm going to show you the help file for save GIF, and so here we can make a movie name. So we'll say let's call this precip flash. Oh, you know what we also want to add is a title. This is going to just flash as we go through. And here we just want to change the interval between these. Let's just make it really fast. Okay, and so now it's going to do 10. I'm actually going to subset that to 5 because it's going to take a second. And it's going to save it to this movie name precip flash.gif because I'm using the GIF generator function. And we can change the animation width, and let's just make it 1,000, and the Annie height. Actually, let's say 500. Annie height equals 400. Okay, so let's run that chunk. And what's going to do is going to generate 5 separate plots that meet the sort of statements in here, and then it's going to stack all those together into a video. We hope. Okay. Okay, so we do have a problem where this station name is going to pop on and off, but basically it's sort of showing this whole thing. We could fix that legend, sort of the dynamics of the legend pretty easily, but just so that we can actually see this full video, I'm going to just go ahead and generate 1 through 365, and then I'll just add this to the end of the video once it's fully generated, because that'll take a while. But that's most of what I want to get it through today, and I'll see you in class later. Okay, so I put the finished video here. It's actually pretty boring. There's only 2 spots, but you can see when the Air Force Academy is has rain or a precip event or Fort Collins, but you know, it sort of doesn't really make any sense. So what I did is I downloaded all the precip gauges afterwards, and this is just a video showing sort of all of the precip gauges, their activity throughout the year. And here you can it's kind of interesting. You'll see flashes of sort of rain events or snow events that cross the whole state. So you're kind of seeing weather systems move in and out. So this is sort of the kind of animation that actually might be much more useful to actually use. See you soon.